Ever thought about learning to code but just didn't know where to even begin? Well, you're in exactly the right place. We're about to lay down the foundational blueprint for Python, one of the world's most popular programming languages. And we're going to do it in just about 5 minutes. Okay, let's jump right in.
So why Python? You hear it all the time. It's celebrated for being both incredibly easy to learn and seriously powerful. I mean, this is the language running behind the scenes on stuff you use every day, like Instagram and Spotify, and even for research at NASA. And the secret to all that success? It's just elegant simplicity.
I mean, just look at this. This is a real, complete, working Python program. And it does exactly what it looks like it does. It prints the words, "Hello world," to the screen. See? It almost reads like a plain English sentence. This whole idea is at the very core of Python's design. So with that in mind, let's start building our foundation. All right, before we can write programs that do all sorts of powerful things, we need a way to just hold on to information. And this brings us to the most fundamental concept in pretty much all of programming: variables. So what on earth is a variable? Honestly, the best way to think about it is just as a labeled box. You put a piece of data inside the box and you slap a name on it. Then later on, whenever you need that piece of data, you just call it by the box's label. That's it. That's really all there is to it. And in Python, this is ridiculously simple. You just pick a name for your box, use a single equal sign, and give it a value. Now here's a super important point. That equal sign does not mean is equal to like it does in math class. In programming, it means a sign. Think of it like an arrow pointing from right to left. We're assigning the text Alex to the variable name, the number 20 to age, and so on. Okay, so this brings up a pretty good question. We've got our labeled boxes, right? But what kind of stuff are we actually putting inside them? Is it text, a number, something else entirely? This leads us perfectly to our next idea: data types. In Python, there are 4 core types you're going to use constantly. Any kind of text, which always goes in quotes, is called a string, or str for short. Whole numbers are called integers, or int. Numbers that have a decimal point, those are called floats. And finally, a simple true or false value is called a boolean, or bool. And if you look, you'll see these map perfectly to the variables we just made a second ago. Okay, so storing single pieces of info is great. But what happens when you have a whole collection of information? You know, like a shopping list or the names of every single student in a class. For that, we need something a little more robust. We need data structures. So meet your new best friend, the list. It's pretty much exactly what it sounds like. Now, the 2 keywords you need to remember here are ordered and changeable. Order just means the items stay in the exact sequence you put them in. And changeable means you can add, remove, or tweak the items whenever you want. And check out how easy it is to make one. You just use square brackets and separate your items with commas. That's it. Want to add a new item to the end of the list? You just use the .append command. This is what makes lists so flexible and powerful for managing groups of data. Now, a list has a sort of cousin called a tuple, and they look almost identical. The only real difference you can see is that tuples use parentheses instead of square brackets. But their core difference is massive. You absolutely cannot change a tuple once it's created. So the rule of thumb is use a list when your data needs to be flexible, and use a tuple when your data absolutely has to stay the same no matter what. Okay, but lists and tuples get you data based on its position, like the first item, the 5th item, and so on. But what if you want to find data using a unique name, kind of like looking up a word in a real-world dictionary to find its definition? Well, for that, we have the dictionary. And the analogy is perfect. You have a key, which is like the word you look up, and a value, which is its definition. And here's what it looks like in practice. We use these curly braces. So on the left side of the colon, that's our key, in this case the text name and age. And on the right side, that's the value. So if we want to get the student's name, we don't ask for the first item. We specifically ask for the value that's attached to the key name. It's so much more descriptive. So we can store data and we can organize it. Great. But now it's time to actually do something with it, right? I mean, if we have a list of 1,000 items, we don't want to write 1,000 lines of code. We want the computer to do all that repetitive work for us. And that, my friends, is the magic of loops. The for loop is going to be your workhorse for this. Its job is really simple. Take a collection of items, like our list of fruits, and then perform an action on each and every single item in that collection, one by one, until it just runs out of items. Let's just break this down because it reads just like an English sentence. The first line just sets up our list of fruits. The second line, this is the important part, it says, for every single item, which we'll temporarily call fruit, that you find inside our fruits list, please do the indented action below. And the action? It's just to print whatever that item is. And this is exactly what you get. The code runs 4 times. The first time through, the variable fruit is holding the value apple, so it prints apple. The second time, it's holding banana and prints that. It just keeps going until every single item in the list has been processed. This is automation in its purest form. It's so cool. Now, sometimes you need a bit more control, so think of break as the big red emergency stop button. If some condition happens that you're looking for, break stops the loop dead in its tracks and the program moves on. Continue is different. It's more like a skip button. It just says, hey, ignore the rest of the code for this one item and just move on to the next one in the list. And just like that, we've done it. We've assembled the core blueprint of Python. We started with variables to store data, then data types to define what kind of data it is, then data structures like lists and dictionaries to organize it all, and finally, loops to actually bring it all to life. And here's the most important takeaway of all. If you understood those 4 concepts we just covered, you genuinely understand the ideas behind about 80% of all the Python code you're going to see as a beginner. Seriously. These aren't just minor details. They are the absolute pillars that everything else is built on.
And that's really the big question, isn't it? This isn't just theory. This is a practical toolkit that you now have. From automating simple tasks on your computer all the way to building a website or analyzing data, the foundation is now yours. So now that you have the blueprint, what will you build?